I'm back again with another update here. I got some new internet, so I'm going to be able to show you firsthand what I've been talking about as far as artificially creating hurricanes. I'm going to show you how this can be proven. I'm going to the National Weather Service cloud top infrared imagery here. This shows you the infrared energy cloud top level. And here you can see, I said in my last video they were having a hard time. Well, they managed to get the motor going with this hurricane here off Mexico. I'm going to try to click on to show the evolution of this system and why I feel it was artificially a created storm and not a natural storm. So I'm on the 24. I'm going to go to the, I'm going to try going to the 240. As you can see the development of this system. Let me get back to it. Now notice the pulsating dark areas you see. That's not natural for that to occur. Now you see how it looks like, you see how in this area, this isn't by accident, or this isn't natural. They're shooting energy into this system. You can see it hitting the system in pulses. It's starting to weaken right now. You can see the dark colors, but there, look right there, right there, right there, another explosion, another one there, another one there, another one, plus some along the bands on the outer part as well to encourage the outflow. Look at all the outflow with this system. This isn't natural either. Normally a natural hurricane is surrounded by an area of upper level high pressure. You don't have all these clouds extending this far out normally from the system, going almost 1,000 miles. So look at all that outflow. If you look very closely, if they did not shoot energy into this system, it would dissipate within 24 hours. They're propping it up. Look at that explosion again. Another big explosion. We had a couple of other systems. System on the last few frames does appear to be starting to weaken because there was a pause in shooting anything into it. And when they pause it, you notice how quickly it starts to fade out. Like look at that. I'm pretty sure that within the next hour or two, more energy is going to be shot into that system to prevent it from weakening and dissipating. But that was one case where I explained in my last video. It was a case where they got the system over the threshold, got it to spin, and they shot a huge amount of energy into it. As you can see right there at that point, they really gave that system a good boost. However, the other systems rapidly dissipated. You can see here, it's the remains of the last system, just clouds now. Reason being that it hit cooler water over the Pacific, and that rapidly dissipated it. You could see the low cloud cover here, which is associated with cooler water. And that storm rapidly dissipated. There's the Hawaiian Islands there. Now we're going to switch over to the Atlantic. And I'm going to show you what I've been talking about on the Atlantic side. So we're going to move over to the tropical Atlantic. Again, the same image we're going to go to, the cloud top infrared, because that is where this energy is going to hit the cloud tops. It hits the cloud tops of these systems. That's where you're going to best see the effects of what I'm talking about. We're going to go over here, take a look at the Atlantic. And there's Florida. This is one of the systems they're claiming could develop into something off over near the Bahamas. But I'm going to come down a little bit here to get a better view of the systems coming off Africa. And we're going to go over to a longer term image here that will go back further in time, because you can see it much better the more time lapse you have. And you can see these, there's a coast of Africa. These systems come off Africa, come across the Atlantic, and threaten the U.S. normally. And I had said that the Atlantic is going to be very hard to get anything going because the energy is missing. Here's one of the systems they're talking about. Again, you can see the extensive amount of clouds covering this region that normally should not be there. Yeah, it is a convergence zone, but normally the clouds should not cover the whole section of ocean. This whole area is not getting sunlight onto the water surface. The oceans are not absorbing that sunlight in this whole area. There is all clouds, there is showers, thunderstorms. Reason being, they're trying to get these systems going into storms, trying to. You can see there's a little bit of a spin to those clouds, but nothing is really organizing at this point. Africa, you can see already they're working on these systems even before it comes off the coast of Africa. Notice how red it is. It's because they're shooting these systems up even before they clear Africa, trying to get them organized into something so that when they come off the coast, their hope is it's going to develop into a hurricane. But as you can see right now, you can see these pulses that look like explosions. They're trying to hit these storms up. And you can see the outflow, excessive amount of outflow, which is what this generates. It creates strange eddies in the atmosphere, like over here. And you can see these storms disturbances are really not doing much because there's no energy in that water right now to supply the sufficient heat to, like, they're really trying with that one. Look at the explosions occurring. They're really trying to get that one going east of the Antilles, Windward Islands. It's right here. This system, they say, could be a threat. Supposedly it's going to go into the Gulf. Not much there right now. But you can see on the last few frames, they've tried to hit that one up as well. But right now, you look at the Gulf of Mexico, the upper airflow is out of the southwest. It's going to be very hard to get a system, for example, to hit Texas with that kind of wind flow. It's going to be deflected back immediately toward the Florida Panhandle. And it even makes it into the Gulf right now, because you could see the flow out of the southwest. There's an eddy over here forming. That's caused by the excessive amount of outflow being generated when they're trying to pump this thing up. It creates a lot of outflow, a lot of extra energy, and it forms eddies in the vicinity, in the atmosphere. And you can see here's the coast of South America. I'm going to try to move this up a bit. You can see the Azores up here. Bermuda is over here, and normally in late August you have a high pressure that extends, subtropical high, from Bermuda to the Azores. They call it the Azores Bermuda High. It's a semi-permanent feature in August. And where that sets up every year varies. This year, it's further south. It's more down in this area rather than up here. That's why we're having, part of the reason we're having such a hard time in the Atlantic getting storms, because if that high presses further south, it pushes this zone further south here. If this is pushed further south, systems have a tendency to go into South America rather than into the Caribbean. What they're trying to do is they're strategically injecting energy in certain areas to try to suck these systems further north so they have a better chance of developing into something. As you can see, even right now, most of the disturbances are moving too far south because this high is too far south right now. You see the Azores are in the westerly zone. They normally should be under that high pressure. They're not. The high pressure is south of them because the airflow there is coming out of the west. And it looks like a cold front just cleared the Azores. So the North Atlantic, you can see this high pressure I'm talking about sits in this zone right here that I'm circling. That's going to inhibit hurricane development in the Atlantic. On the other hand, in the Pacific side, if things are pushed further south, it actually increases the chances of Pacific systems, because you got this zone here with very warm water that opens up from that high being pushed south. This relates to solar cycle 25. I did say that the sunspot count, I'm going to see if I can go to that page here, space weather, and show you the figures here. And you can see currently there's 135 sunspots on the disk. It had dropped below 100 a few days ago. It's gone back up because we have some more rotating interview here that brought it back up. But I had said that the maximum this cycle is probably going to be about 150. So it's holding in that vicinity right now. Now the cosmic ray count has been down lately. I'm going to go to that. It's down minus 2.2, but I'm going to put things into perspective here with that. This goes back to solar cycle 20. This here is solar cycle 20. In solar cycle 20, the cosmic ray count went down, which was considered a weaker than average cycle, the only one in the 20th century that was weaker than normal. You can see it spent about 2 years around the minus 5 zone, came back up around 1971, and stayed up until almost 1980. That's why the 70s were a cooler decade, because we had that extended period of higher levels. There's a higher cosmic ray count, the more clouds, less sunlight, cools the atmosphere. This now, in contrast, the natural global warming, you can see how short it only went above, the cosmic ray count only went above average for just 2 years between cycle 21 and 22. Cycle 22, 1991, it went all, the ray count, cosmic ray count went all the way down to minus 20 in 1991. That resulted in some natural warming. The 90s, it went up for a longer period. We did get some cold winters in 1996, 93, 94, and then we went right into 23, which spent, let's see, about 4 to 5 years down in the minus 5 zone. Then you can see what I've been talking about. Around 2007, look at how high the count went. 24, look at how weak that cycle was. The count barely came down below average that whole cycle, and shot back up again. Of course, now we've gone back to minus 5, but you can see in the last month the trend has been back up, gradually coming back up. And right now we're at minus 2, which is pretty much where we were for at times during cycle 24 back in 2008 and 2012, 13, 14. We were around minus 1, minus 2 a lot of the time. We're at about a little over minus 2 now. So you can see this next cycle, 25, so far has been only maybe a bit stronger than 24. The lower this goes, the stronger the cycle. You can see how strong 22 was. 21 was pretty strong. You can see how long that lasted. And so, look at in comparison, the 21st century figures. That's giving you a clue that we're in a new regime for solar activity. You can see the difference here between what was going on in the 20th century so far. So the question is, are we going to have an active season? Well, the Pacific side still has some warmth, with the favorable placement of the high pressure being a bit further south. That's what caused the heat waves down in Florida, in Texas, in Arizona. That high was sitting, as I said a couple videos ago, further south than normal. And where that high sits is where it's going to be the hottest. So that's going to be it for this video. I'll probably be with more updates soon.